Welcome to the third week of the class where we're covering themes from chapters 5 through 8 of the book we're working through, Calling Bullshit. So one of the big themes, chapter 6, is all about selection bias, and we discussed it a little bit in the discussion questions from last week. But the basic idea here is you're looking at a group that is not representative of the larger population that you want to look at. So one example that I think is somewhat fun comes from the book Everybody Lies by Seth Stephens-Davowitz, who suggests that, essentially there's this huge difference between what people search on Google and what they put on social media. Your social media post may be all about a great vacation you just went on, and your Google searches are about tropical bug bites, right? Like the idea here is that you're only seeing a limited subset at any one time, in this case of what people want to present. And there's lots of really interesting examples in that book that are a lot more in depth. And then, a very common form of this is asking successful people about what causes success. And the problem with this is that you're not asking the unsuccessful ones, so you don't actually know. Like, most people are not walking around thinking about causal inference all the time unless they're, professional econometricians or something. So successful people can tell you what they did, but they don't necessarily know, were there unsuccessful people who also tried that same strategy? We're willing to attribute in life this idea that, like, if you buy a lottery ticket, it's pure luck, right? So we don't think that the person who bought the lottery ticket did something to win, right? Like, they were lucky. And the problem is that a lot of life is a combination of both luck and skill. And it's very difficult to disentangle what happened there. Like, were you at the right place at the right time with the right set of skills, and this is why you're successful? Possibly. Could you have tried that same approach but just missed one lucky break and not wound up successful? That's also possible. Like, obviously having a broad set of skills is a good thing. On net makes you more likely to be successful. This is not about, like, taking away credit from people for all of their hard work and the things they do to set themselves up for success and all that. But it is about acknowledging that, like, there are also unsuccessful people who tried many of those same things and were not successful due to, some bad luck, something overlooked, etc. And if we really want to disentangle, like, what are the things that increase your probability of being successful, you have to do a comparison between successful and unsuccessful, right? Another really good example from politics is that polling selects only the people who are willing to be polled. So for a while, this was a problem with, like, landline-based polling. People didn't answer their landlines, and those who did were older and home during the day, right? Which is not like a representative block. People with cell phones who eventually gave up landlines or at least didn't answer them wouldn't have been included in those polling. Now, mostly pollsters were able to do some combination of, like, cell phone based polling and even online polling and use representative sample weights and get things more or less okay. And then there was a new problem, which is we had this problem with institutional trust and responsiveness to polling in any form. So people with low trust in institutions are just less likely to answer polls. The problem is that people with low trust in institutions are more likely to vote for anti-government politicians, and in particular, people with low institutional trust are a lot more likely to vote for President and now candidate Donald Trump. So this was the biggest issue with polling. The other issue with polling back in 2016 was largely overconfidence in the polls and in how uncorrelated different states might be. But to the extent that the polls themselves and not just the interpretation had an issue, it was this institutional trust problem with essentially not having the right selection of people included in the polling. Yeah, I'll just pause. This is basically the lottery example I just gave. Okay, so that's selection bias. It gets its own chapter because it's just a super common form of data being misleading and people essentially telling a false or misleading story. So then we have a chapter on data visualization, and all of the advice is good. If you want something more in depth, I highly recommend the book I've got on the slide here, Storytelling with Data. It's something that I worked through with all of my team when I was a data science manager at Brown-Forman, because I think it does a really good job with explaining like how do I actually put the data into a story that's going to move people who are not data scientists, but who are busy professionals who are looking to make a decision, looking to understand what's going on. And so, the basic principles that she goes through in the book are understand the context, choose an appropriate visual display, and I'll pause and say, please don't use pie charts for data over time. Many people would say just never use pie charts. If you are going to use pie charts, please no more than like 3 categories. Please don't do it with data over time. Please make sure it adds up to 100. And, maybe consider not using pie charts. Eliminate clutter. So this one is, I think, possibly the single best piece of advice to give to people who are new to making charts. There's a temptation to use whatever effects that you can put into it, make it 3D, do something fancy with it, add some animation, add some colors. This is generally a bad idea. You want to focus in on just the point you are trying to make, which brings us to the next thing. Focus attention. So you can sort of gray out context in the background. Make sure that the title of your chart actually says the thing you want them to know. Like your chart should not be bourbon sales between 2000 and 2020. Your chart should be, there was a bourbon boom starting in 2010. It seems to have plateaued around 2018, right? Like that was a little long because I'm doing this on the spot. But the idea is like your headline should be informative. It should actually say the conclusion. So related to tell a story, lead with the ending. And you'll note from Storytelling with Data that already, this is better than the slides that were before. We've got this nice little narrative arc and visuals of the 5 things that we really want to focus on when we do data viz. And then this is just an example, some things I like you can tell the line chart, in the first one you can sort of tell like this black line is what we're looking at, but you have to bounce back and forth and you just have like colorful spaghetti going on in that line chart. It's not good. In the next one, you still have spaghetti, but you've grayed out the background so people aren't distracted by it. They can see because you've bolded regional average. You've gone ahead and put the key right next to the line so that you're not flipping back and forth. And then you've added another chart that really gets at what we see in here. You look at this line chart, and for some things a line chart is a great idea, but I'm not really seeing a story over time here. 2017 to 2019, a bunch of dealerships bounced up and down a little, but we probably actually want the summary view, which shows our regional average is somewhere in the middle, and then gives us a bit of these are the cars doing really well, and these are the ones doing really poorly. So dealerships, not cars. Okay. On big data, I think the one thing I'm just going to talk about quickly is how machine learning is actually a change from what came before. So in classical programming, or classical statistics for that matter, you have some rules, you have some data, and you get some answers. You minimize the sum of squares, or you make this chess move when the board looks like that, right? It's usually fancier than if then, but it's still like someone sat down, came up with these are the rules that we should use. It's going to give us the answers. In machine learning, you input the data and you input the answers, and then you allow the machine to come up with the rules. And the reason this is somewhat important is because the rules may not make sense, particularly with deep learning, which is a form of machine learning, also called neural networks. You wind up with rules that are basically more matrix algebra than any human being could ever pay attention to. And so there's some work on can we eventually interpret this? But frequently what you actually know from machine learning is that it found a route from the data to the answers, and then you gave it a separate set of data where you still knew the answers, but you didn't give them to it, and you tested, and it did well on those answers. But you don't necessarily know how. Like, we don't really know what AlphaGo is looking at when it plays Go. We just know it's really good at playing Go. And so on, obviously, like Go and chess, I mean, while we'd like to know for curiosity and maybe to teach ourselves to be better at board games and so forth, we're not as concerned. But the problem is, like, a lot of machine learning is being used, particularly when it's used in civic fashions and in policy where we might be concerned with it. We probably really want to know what the rules are. A good example of one that wasn't deployed, Amazon tried to train something on past hiring to predict, successful hires, and they were eventually able to, interpret in this case and come to the rules when they looked at what it was doing. It turned out it was, largely hiring people named Jared who played lacrosse. Like, both of these are huge socioeconomic indicators, also indicate some degree of sexism in the hiring process, etc. But this is also what's going to happen if you train data on, or if you train the machine learning algorithm on past data that already had these flaws in it. Like, you get rules that codify all of your past informal practices. And if your past informal practices were bad or sexist or racist or any of the other problems that, you might run into on a set of training data, then you will just be formalizing those rules into your new machine learning system. Fortunately, in this case, they were visible. It was a simple enough system that engineers were able to pick up on it. It was never deployed, etc. But in some cases, we don't even know what the rules are. And in that case, like, how do we actually know if it is behaving or picking up on some underlying sign that we are not aware of? And this is just to say, like, subject matter expertise still matters. Big data by itself is not enough to solve everything. Okay, I want to do a case study here of a machine learning algorithm that's currently being used in Allegheny County, which is the county that has Pittsburgh in it. So this will be a bit more in depth than some of the examples I've just tossed out in the past. Cathy O'Neil wrote the book Weapons of Math Destruction, which really kicked off a lot of this period of interest in terms of how our models affecting our everyday life, how our mathematical models. And really what I think is the key insight from this book is, like, models are in fact someone's opinions embedded in mathematics. There's judgment all the way through in terms of what data goes into the model, how the model's set up, how you validate the model. Like, all of these are opinions that someone is putting into the system. So it is not the case that you wind up with some objective output when you are still dealing with a bunch of subjective inputs, right? Okay, so the Allegheny Family Screening Tool, it's a product of Allegheny County, and it's run by the Office of Children, Youth, and Families. And the goal is to determine which reports of suspicious circumstances are most likely to be child abuse or neglect. And about 3/4 of the investigations are about neglect. I mention that in part because neglect is often trickier in terms of both the definition and the evidence. There are often not physical signs the way you might have in an abuse case, and there's a question of, like, how long was the child alone, etc., etc. So the database is created in 1999, so quite a while ago. Has 1 billion records, which is like 800 per every person in Allegheny County. There's 29 different programs that send extracts, and I want to give some examples because this will be relevant later. They're the unemployment office, local school districts, the housing authority, the police, jail, juvenile probation, drugs and alcohol services. And the program costs about $15 million a year, which is 2% of the budget. So it originated in New Zealand with a team of academics. It has a predictive model with 132 variables. Note, this is just predictive. There's no causal nature here. Like, we're just saying this data was correlated with this other data within the system. So length of time on public benefits, past involvement with the child welfare system, the mother's age, born to a single parent, mental health, and correctional history. So accuracy was fair, approaching good in the academic self-assessment, but New Zealand did shelve this after a new social development minister took office, and instead it went live in Pittsburgh back in 2016. So AFST is step 3 in a 3-step process. In theory, with the Child and Youth Services, is going to say, does this meet Pennsylvania's definition of maltreatment? Is there present or impending danger? And then finally, a risk score based on family history. So ideally, the screeners are going to understand the question in the model. I want them to be able to say this screening score is a 20, but this allegation is so minimal that all this model is telling me is that there's a history. And I forgot to mention at the beginning, I'm taking this case study from the book Automating Inequality. So the question is like, do we think this is actually how models get used? The problem is there's a tendency to defer to machines. And even if people know not to do that, they're still likely going to be held accountable. Like, you can imagine the case where someone from Child and Youth Family Services doesn't want to pass on something where the AFST risk score is very high, because if they pass on that and they're wrong, well, they're in a bunch of trouble. Okay, so the choices that were made here, we chose the outcome variables, the prediction variables, and the validation data. So there's a few possible metrics we could think of for like child abuse and neglect. We could do actual fatalities and near fatalities of children, and thank God there are not actually enough of those to build a model on this data. Still too many, but like not enough for doing that, so that rules that out, right? We could do substantiation of child maltreatment. Child and Youth Family Services substantiates when there may have been maltreatment, but because the systems are tied in together in weird ways, apparently they also occasionally substantiate to help families get access to food stamps or affordable housing. Stepping back to the actual fatalities or near fatalities, I'll also say, like, this is why with crime data, people often look at homicide rates, because in general, not just child abuse and neglect, but like just defining crime or measuring how much crime occurred in the US or comparing it, in particular if you want to compare it across cities or states, there's no real way to do this. People often use homicides on the grounds that like a homicide is more clearly defined and the same everywhere, although even this is an imperfect data source. In short, like I'm saying, US crime data just isn't very good, and it's very hard to actually work with and have confidence in the data. So, however, back to our main point about the AFST, the system uses 2 proxies. Community re-referral, which is a call to a hotline, is initially screened out, but there's another call, just another call, not another like substantiation, within 2 years. Or child placement. The child is placed in foster care within 2 years. So the thing is that we're actually predicting are decisions made by the community. Which families will be reported to the hotline? And then by the agency and family courts, which children will be removed from their families. We're not actually predicting which children will be harmed. Just 2 proxies that we think are related to children being harmed. So the problem with that approach is that we actually know that the people who are most likely to have their neighbors call Child and Youth Services on them are people of color. And similarly, there are racial biases within the courts in terms of like children being removed and placed in foster care. Okay, so the prediction, they use stepwise appropriate regression. This is not the main point. I don't like this methodology. Strongly recommend if you get into econometrics or data science at some point, use Lasso, which is least absolute shrinkage selection operator, and not a reference to the fabulous TV show Ted Lasso. Or use a tree-based method, random forest, gradient boosted model. So AFST tested 287 variables from the data warehouse, used 131 of them, and there's nothing in the method to justify causal inference. It is purely a predictive model. They were tested on referrals between 2010 and 2014 and have 76% accuracy. So this is Virginia Eubank's assessment, and I am going to go ahead and read this one. The AFST has inherent design flaws. Virginia Eubanks is the person who wrote Automated Inequality, from which this case study came. The AFST has inherent design flaws that limit its accuracy. It predicts referrals to the Child Abuse and Neglect Hotline and removal of children from their families. Hypothetical proxies for child harm, not actual child maltreatment. The data set it utilizes contains only information about families who access public services, so it may be missing key factors that influence abuse and neglect. Finally, its accuracy is only average. It is guaranteed to produce thousands of false negatives and positives annually. So the data warehouse only has data on public programs, not private ones. And this is a problem because if you have the resources and go to private school care or private mental health or any of these, you are not in the system. The other thing is that Child and Youth Family Services has two roles that contradict. They provide family support and they investigate maltreatment. If someone's having a mental health crisis, they should get mental health support and not worry that they will later be punished with an increased risk of being investigated by Child and Youth Family Services for maltreating their children. Like, they should get the treatment and support they need so that they are in fact less likely to wind up neglecting their child because they were not healthy enough to pay enough attention, right? So like, you want them to have access to this support that in fact makes neglect less likely to occur, and yet you're using getting that support as an indicator of potential neglect, and so potential punishment and deterrent from people getting that support. So bias in child welfare services comes more from referrals and screening. I mentioned this earlier, but the community is more likely to call about non-white families. And then, again, Eubanks, the model confuses parenting while poor with poor parenting. And this is, again, because if you are poor, you are more likely to be reliant on the services and thus more likely to be in their database and thus more likely to have a higher family risk score. So the cost of errors here matters. Like, opening an investigation is in fact an intrusive and frightening event for families that carry, very real and frightening consequences for parents, right? We do, of course, obviously want to catch actual instances of abuse and neglect and address those. But we do have to balance this with not arbitrarily invading families, right? Like, this is a tricky balance that it's not the main point we're getting into here. But in terms of thinking about the model, I'm saying we do need to care about both false negatives and false positives here. So once the big blue button is clicked and AFST runs, it manifests 1,000 invisible choices, but it does so under a cloak of evidence-based objectivity and infallibility. And my point here is not even that algorithms can't be helpful. Compared to what came before, it's possible this is better. Maybe the Allegheny family screeners were in fact all wildly racist. Historically speaking, I don't think this is actually true, based on what we read in the case study. But the point is, you could have a terrible human system that's being replaced by a bad machine learning system, and it's still an improvement from terrible to bad. We always want to think about what is the actual alternative to these systems. But we don't want to confuse them with some sort of objective system that is giving us the right answer or completely unbiased with random errors. It makes errors in ways that are reflective of the data and the decisions that went into the program. There's also this possibility that by increasing social isolation, material deprivation, and parenting stress, the model could wind up increasing the risk of child abuse. This is what I was talking about a bit earlier when I suggested maybe it's a deterrent for people getting resources that they actually need. But if that's the case, that would mean the model starts partially producing the outcome that it's trying to measure, which is a problem when your model becomes self-referential. You can no longer measure the actual accuracy of the model once the model starts intervening in the system. So the other question, with this is, in many regards, this system tried to do things well. Tool design was open and participatory. Implementation was relatively thoughtful and slow. The goals were pretty modest. We're not trying to replace human screeners. We're trying to support their decisions. I think the biggest issue and the biggest gap we have here is there's no real good way to access the ongoing performance of the tool. Like I mentioned, the validation data being from what is now 10 years ago. There's not really an ongoing way to test it once it keeps going. Okay, that's the case study. Going to be a lot to talk about this week. These are the questions to discuss in Slack, and look forward to talking to all of you there and seeing you all next week.